Welcome to Daud Networking Labs. This is CCNA 200-301, Day 7. We're going to be covering VLANs and Interswitch connectivity. Today we have finished, in last episode we finished 1.0, which was 20% of the CCNA exam objectives, and now we're switching on to network access. Remember, the first 1 and then 2 and 3 are the most important sections, and if you can pass those really well, then you'll pass the CCNA with almost certainty as long as you do okay on the others. Let's begin. So, today we will be covering network access and configure and verify Interswitch connectivity. So, let's start with the first scenario. Let's say you have two switches, switch 1 and switch 2. I will teach you how to configure VLANs that span the two switches. Okay, so first step, you configure the VLANs. So you'll hit a classic conf t, and then the command to create a VLAN is VLAN 10. And then you're in the VLAN config, so you write name, and then you write the name that you choose. In this case, mine was in sales. And then exit, and you repeat. And then after that, to assign interfaces, we'll go to interface range, or interface whichever one you want. If you want to use range, you add in range so that you can choose many ports. And then you do switch port mode access, and then switch port access VLAN 10. This is super simple, and you can mostly tab through most of it. As long as you pick it up, you can do this in like a minute. Alright, so then, step 2, you configure the trunk links between the switches once you've configured that. So you do conf t interface to trunk port, and switch port mode trunk, switch port allowed VLAN, and then whichever VLANs you want. Same thing on switch 2. Third step, how to verify the VLAN and trunk. You just do a classic show VLAN brief, this is the best, or to check the trunk, show interfaces trunk. So, let's ask how to configure access ports. To configure access ports for both data and voice VLANs on a switch, you need to use the switch port voice VLAN command. This allows the port to carry both data traffic for computers and voice traffic for IP phones. So, I'll do the same step by step again to show you through the entire thing. So, how do we configure access ports? So in this case, we have two VLANs. VLAN 10 is data and VLAN 20 is voice. Alright, so basically, do the same thing, make sure the VLANs are defined, so VLAN 10, name, and VLAN 20, name. Yeah, and then after that, you actually configure the ports. So, you conf t, interface, and switch port mode access VLAN 10, and switch port voice VLAN 20. Remember this is how you make a voice VLAN, switch port voice VLAN, not voice access. So, and if you want to configure many ports, you do the interface range command. To verify, same thing, show VLAN brief, and this will confirm all these things. So, what happens is, by configuring both access points with both data and voice VLANs, you enable the port to handle traffic from both computers and IP phones. The IP phone tags its traffic with the voice VLAN, VLAN 20 in this case, while the computer traffic remains untagged and is assigned to access VLAN, VLAN 10. This setup ensures proper segmentation and prioritization of voice and data traffic on the network. So, default VLAN. The default VLAN on most switches, particularly Cisco switches, is VLAN 1. By default, all switch ports are assigned to VLAN 1, unless they are explicitly configured to be a part of another VLAN. So remember, the default VLAN is VLAN 1 unless it's changed. The default VLAN serves as several important purposes in a network. It's in the initial port assignment, because when a switch is not configured to a specific VLAN, it goes into VLAN 1 by default. And management traffic, because by default management traffic such as CDP, Cisco Discovery Protocol, and VTP, VLAN Trunking Protocol, is transmitted over VLAN. And then trunking, which is on trunk links, VLAN 1 is the default native VLAN, which means that any untagged traffic on the link is assumed to be a part of VLAN 1. Managing the default VLAN. Although VLAN 1 is the default, it is often a best practice to avoid using VLAN 1 for user data traffic due to its potential security risks and to prevent interference with management and traffic. In the next slides, I will show you how, step by step, in a simulator, which is Packet Tracer. If you want to follow along, run it in your own Packet Tracer and do it. So, setting a default VLAN. So let's say we want to set up VLAN 99 as our new VLAN. So we'll do this. Configure terminal, VLAN 99, make it. Then after that, interface whatever, and switch port mode trunk, switch port trunk native VLAN. That's how you change the native VLAN. And then you just do classic, same thing, switch port trunk native VLAN. That's how you set it up. So, summary is, while VLAN 1 is the default VLAN on most switches, best practices recommend avoiding its use for data traffic due to potential security risk and management traffic interference. And by changing the native VLAN on trunk ports and assigning access ports to different VLANs, you can enhance the security and manageability on your network. So, connectivity. Ensuring connectivity between devices in different VLANs and verifying that everything is set up correctly involves several steps, including configuring inter-VLAN routing and performing connectivity tests. Here is a comprehensive guide to ensure connectivity in your network. To allow devices in the different VLANs to communicate with each other, you need to configure inter-VLAN routing, which can be done using a layer 3 switch or a router. So let's start with layer 3 switch connectivity. So let's assume these following. So we create the VLAN interfaces, which are also called SVIs. So you interface VLAN 10 to throw an IP address on the VLAN, you IP address and then whatever, and then no shut. Same thing again. Second, you enable IP routing. For layer 3 switches, this is the key. You have to enable IP routing. This will allow it to route the IP addresses. Then, next up is something called router on a stick. This is another form of VLAN inter-VLAN routing. So, router on a stick is where you create the sub-interfaces on the router. So you'll do interface, say G00, and then you do 0.10 for VLAN 10. And then you have to do an encapsulation, and then an IP address. And then you do the exact same thing. Interface gigabit, whatever, 0.20. And you just repeat, and then at the end, IP routing, and you're done. Then you have to create a switch trunk port to the router. So you go to the switch, interface it, switch port mode trunk, switch port allowed, and then boom. And to confirm, you do a ping. If it works, it's good. If it doesn't, you messed up. And if you follow these steps, you'll be able to configure inter-VLAN routing quite easily. Go through many of my suggestion is go through many of the Netacad free packet tracers. They're great. And it'll just get your hand running. So then once you are in the CCNA labs, if you get a question like, say, like make VLANs, you can like breeze through it because it's easy for you. So how to configure a trunk. We basically covered this, but I'll cover it again. To configure and verify interswitch connectivity, you have to set up trunk ports. Configure them using an 802.1 encapsulation and ensure the native VLAN is properly set. Here's a detailed guide on how to achieve this. So you do a conft interface fast Ethernet 0/24, switch port mode trunk, switch port trunk allowed VLAN, and then that's it. Same thing again. 802.1q is the default encapsulation type for trunk ports on most modern switches, including Cisco switches, if you need to explicitly set it. So, there it is, encapsulation.1q. You should be able to tab, just write encap and it should do it, the job. Configuring native VLANs, yep, this is exactly what we just covered. Interface fast Ethernet 24, switch port trunk native VLAN 99, and that would set your VLAN. So, by following these steps, you have configured and verified the interswitch connectivity, ensuring the trunk ports are correctly set up with 802.1q encapsulation and the appropriate native VLAN. This configuration facilitates proper VLAN traffic handling across multiple switches, ensuring seamless interswitch connectivity. Alright, let's get to the practice questions. What command is used to assign a port to a specific VLAN for data traffic? The answer is C, switch port access VLAN. So, the reason is, switch port access VLAN command is used to assign a specific VLAN to an access port. This is important for defining which VLAN the traffic on a particular port belongs to. What is the default VLAN on most switches? The answer is A. Reason being, VLAN 1 is the default on most switches, and this is going to be the default VLAN unless they're explicitly covered or configured by another part, like a user. Which command enables trunking on a switch port? Answer C. This command allows you to create a trunk on the switch, which allows it to carry multiple VLANs. Which encapsulation type is commonly used for VLAN tagging on a trunk port? 802.1q, 802.1x, VTP, or ISL? Answer is B, 802.1q. Remember this, you'll need it. 802.1q is its standard encapsulation type used for VLAN tagging on trunk ports. It allows traffic from multiple VLANs to be carried over a physical link. Thanks so much for watching. Make sure you do your other practice questions. I'd suggest free resources, pass them all. It's in the description. And if you want to have your own resources, go ahead. But all I want you to do is show your appreciation of this course if you're really liking these videos. Just like, comment, and subscribe, and thank you so much. And also there's a link to my Patreon in the description below if you really love this class, and if I helped you get the CCNA and you really want to give me a donation of appreciation, that's where to go. Thanks so much for watching. Have a great day.